we've previously seen how two atoms, so if this is atom 1 and this is atom 2, we've previously seen how two atoms like this can be involved in an electron transfer, which causes them to turn into ions. So we'll say that this here turns into a positive ion, and this one here turns into a negative ion. Now, if you're not sure how that works, I suggest that you go back and watch the video on the formation of ions. What we then learned is that because that these two ions have opposite charges, that they're attracted together by an attractive force called the electrostatic force. So the electrostatic force is a force of attraction between oppositely charged ions. And this causes these two ions to become essentially stuck together like this. So we'll draw them stuck together. And we said that simply this is known as an ionic bond. Okay, today we're going to take that idea and we're just going to make it just a little bit more complicated than that. Okay, so an important thing to remember, I'm going to read a little bit of stuff here. An important thing to remember is that when we carry out a chemical reaction, we do not just use one or two atoms like we're drawing. When we're drawing them, it's simple to just draw one or two atoms. But when we're doing a chemical reaction, really we're talking about billions of atoms reacting together. Now, because the electrostatic force works in all directions, not just between two ions, it works in all directions, that once these oppositely charged ions are formed, all these billions of atoms can be attracted to each other. So it's not just two atoms stuck together. Yes, we draw two when we're drawing it because that's simple to think about, but the electrostatic force doesn't know like, okay, well, I'm going to attract that particular ion right there and only act in that force. It acts in all directions. So we've learned that what this creates is it creates a giant structure. So it creates a massive structure of ions stuck together. So when ions form a giant structure, it is called a giant ionic crystal lattice. Okay, so that's what we're learning about here. These things called giant ionic crystal lattices. Okay, so what does it look like? Well, this here is a representation of a very simple ionic lattice. Okay, so as you can see, the yellow or orange arrows here represent the strong electrostatic force of attraction, otherwise known as ionic bonds. And what you can see is them acting in all directions. But what the really important thing here is to remember what's actually going on. So if we go over here and we think about here, so if we say that in giant ionic lattices, then if we take something like this, for example, NaCl, sodium chloride, we've done this when we were talking about the formation of ionic substances. And we learned that what NaCl means is it means one Na and one Cl. But it doesn't literally mean just one of each. It means one Na, sorry, for every one Cl. So in ionic substances, these formulas are more like ratios. So we say that the ratio of ions here is one Na to one Cl. Yes, in reality, there are billions and billions of these, but that's a really important thing to remember, that in ionic lattices, this NaCl does not literally mean only these two ions together. It means for every one sodium, there's one chlorine. And that's what you see here. There's the same number of positive and negative ions. And this would be the lattice, the ionic lattice for literally any one-to-one ionic compound. So one-to-one ionic compounds, their lattices will look like magnesium oxide. So one magnesium for every one oxygen. That would look like this as well. Positive magnesium and negative oxygens. Another one we would have learned about is potassium fluoride. One potassium for every one fluorine. Now, again, you don't really need to know the different types of crystals, but I'm just showing you, for example, what happens if it's not a one-to-one giant ionic crystal lattice. Well, let's take a look at this one, for example. Now, again, this is just for your information. It's not something you need to be able to draw or know, but it's just interesting, I think. This here, what you see here is a crystal lattice for a substance with a 1-to-2 ratio, okay? And you can see that if you count them, there are twice the number of green ions as there are red ions in this case. So out of the examples that we did, this might be something like MgCl2. This is an ionic substance. It forms a giant ionic lattice. And in this case, there is one magnesium for every two chlorides. So here, the red ones would be the magnesium, and the green ones would be the chlorides, and there's twice the amount of green ones. So I'm hoping that you understand that, okay, that again, these formulas for ionic substances tell us the ratio of ions that's in the giant crystal lattice. And that's the way the structure of basically all ionic substances, they form these crystal lattices. Okay, well, let's see some kind of detailed explanations of what we might be asked about something like this. So here's a typical question where you might be asked to see if you really understand the difference between structure and the bonding of things. Along with me, I'm reading this here, example question. Let's see what we're asked to do. We're asked to describe, so we're looking for a description. So this isn't going to be just, a couple of words. It's going to have to be a description. The structure and bonding. So I'm going to break that into two parts for myself. I suggest that you do the same. I'm going to say, okay, talking about the structure is one part of the answer, and number two, talking about the bonding is another part of the answer. So what I want you to do here is I've given you two sample answers. One of them, this one here, I consider to be an excellent answer. And then this one here, I consider to be a poor answer. So what I want you to do is pause the video, and I want you to read these two answers. Do that now. Pause the video, read the two answers. Okay, so you should only be watching if you've paused and read them very carefully. I want you to pause again now and basically try and compare them. What are the differences between the two answers? Okay, so pause the video, do that now. Okay, so I'm going to go through this with you here now and show you why I think this first one is a very good answer. Well, first of all, I mentioned in my name what the substance is, sodium chloride. That's good because we were asked about sodium chloride in the question, so that's always a good start. And look here, it's giving us detail. It's telling us about the structure, first of all. It's a giant ionic lattice. So there is information about the structure. And what is it made of? The lattice is made of, and look, it's given us the specific names of the two ions. It's made of sodium ions, positive sodium ions, and negative chloride ions. That's a really good answer about the structure. And that's that bit of the answer probably covered fairly well. Then it goes into explain the bonding. Because these ions are oppositely charged, they are held together by, oh, I love this, electrostatic force of attraction. So it's given details about how the bonding works. What is the bonding? Because that's what we're asked to do, describe the bonding. So this is describing how are these things held together. Because the force acts in all directions, you can form a giant lattice of alternating positive and negative charges. Hopefully for anyone, this is the only word here I predict that some of you mightn't understand. Alternating means like every second one is positive and every second one is negative. So it's like positive, negative, positive, negative, positive, negative. That's what alternating means. It means if you've got two opposites, alternating means you switch from one to the other. Positive, negative, positive, negative, positive, negative. And if you look at the pattern here, that's what you have. Negative, positive, negative. And the next one here, if there was another one, would be positive, negative, and so on. So it's like an alternating pattern. All right, why is the second answer a poor answer? Well, first of all, it doesn't mention that we're talking about sodium chloride at all here. So it doesn't mention that. Yes, it mentions by name the two atoms. It says that they form ions, but that doesn't really, doesn't talk about the bonding really. Doesn't talk about the bonding. It just says they're stuck together. That doesn't describe the bonding, it just says stuck together, not really detailed enough. By bonds in a large structure. And again, no mention of a giant ionic lattice. So that's not a description, it just says a large structure. Again, massively that answer can be improved. All right, so you've got some questions to do now. So what I'm going to get you guys to do is I'm going to get you to pause the video and do these. But before you go, what I want you to do is I want to just give you a little bit of guidance with these. In question 100 and question 102, let's read them. What type of question are these? It says describe, so be careful, describe in terms of electrons. What happens when sodium reacts with chlorine? So talk about the electron transfers involved. Electron transfers involved. Describe the electron transfers. Okay, so essentially what you're doing there is you're describing in words the ionic dot and cross diagram for that. So it might help you to draw right out the ionic dot and cross diagram for this first, and then describe in words what's happening and what's being made. Okay. All right. So 102 is very similar then. What's the difference between 101 then and 103? Well, these say to describe the structure and bonding of these two things. Now, this is very similar to this question up here. So my advice to you is to use what I would consider the excellent answer up here to help you draft your answers. for 101 and 103. I think by using this excellent answer up here, you can't go wrong. I think you should be able to write a great answer for those two and really get stuck in to having good quality written answers here. All right, guys, that's that for that the structure of ionic compounds. We'll see you in the next video.